$60. That's all it took to turn Chrysler's engineering hierarchy upside down. While Dodge was charging customers an extra $2,000 for their legendary 426 Hemi, a Pennsylvania mechanic named Dick Landy discovered something that would shake the entire Mopar racing world to its core. He could make a standard 440 Wedge engine compete with the mighty Hemi for the price of a tank of gas and a nice dinner. Picture this. It's 1968, and you're standing in the pits at York US 30 Dragway in Pennsylvania. The air is thick with tire smoke and racing fuel. Big block Mopars are everywhere, but there's a clear divide. The guys with deep pockets are running Hemis. Everyone else is trying to make do with 440 Wedges, knowing they're giving up at least 100 horsepower to those exotic hemispherical combustion chambers. But in one corner of the pits, Dick Landy is quietly installing what looks like the wrong valve springs in a 440. The Chrysler engineers watching him think he's lost his mind. They're about to learn otherwise. This is the story of how one mechanic's curiosity exposed a massive oversight in Dodge's engine program and created one of the most legendary performance hacks in drag racing history. A modification so simple, so cheap, and so effective that it made Chrysler's most expensive racing engine look like an overpriced luxury. And it all started because Dick Landy asked a question nobody else thought to ask. What if the 440's biggest limitation wasn't its design, but a single component that cost less than a carburetor rebuild? To understand the genius of Landy's discovery, we need to travel back to 1966 when Chrysler introduced the 440 cubic inch RB engine. This was the era of the muscle car wars, when Detroit's Big Three were locked in a horsepower arms race that would define American performance for generations. Ford had their 428 Cobra Jet. Chevrolet was dominating with their big block 427. And Chrysler? They had two very different answers to the horsepower question. At the top of the Mopar food chain sat the 426 Hemi. This was exotic machinery, an engine so dominant in NASCAR that it literally got banned after winning 37 of 48 races in 1964. The Hemi's hemispherical combustion chambers allowed for massive valves and incredible airflow. With dual 4-barrel carburetors, it was rated at 425 horsepower from the factory, though everyone knew that was conservative. Real-world dynos showed closer to 470 horsepower. But here's the thing about the Hemi. It was expensive, really expensive. The engine option alone cost $800 in 1968, which is about $7,000 today. Add in the mandatory heavy-duty transmission and rear end, and you were looking at a $2,000 premium over a standard big block car. Enter the 440 Wedge. This was Chrysler's volume big block, designed to be everything the Hemi wasn't. Where the Hemi was exotic, the 440 was conventional. Where the Hemi required special parts and knowledge to maintain, the 440 could be serviced by any competent mechanic. The 440 used traditional wedge-shaped combustion chambers, a single 4-barrel carburetor, and hydraulic lifters that didn't require constant adjustment like the Hemi's solid lifters. In street trim with the 4-barrel carburetor, it was rated at 375 horsepower. Respectable, but not earth-shattering. But here's where things get interesting. The 440 and 426 Hemi shared the same 4.32-inch bore spacing. They used the same engine blocks, the same connecting rods, and many of the same internal components. On paper, the 440 actually had 14 more cubic inches of displacement than the 426 Hemi. So why was it down by nearly 100 horsepower? Dodge engineers had designed the 440 with specific priorities. This engine needed to be smooth, quiet, and reliable for luxury cars like the Chrysler, New Yorker, and Imperial. It needed to idle smoothly in traffic, start easily on cold mornings, and run on regular gasoline. To achieve these goals, they made certain decisions. The camshaft was mild, with just 256 degrees of duration and 0.450 inches of lift. The compression ratio was a modest 10.1.1, and the valve springs? They were specifically chosen to be soft. Those valve springs were rated at just 90 pounds of seat pressure and 240 pounds open. For a street engine that would never see more than 5,000 RPM, they were perfect. They reduced valve train wear, made the engine quieter, and put less stress on the camshaft and lifters. The Chrysler engineers had tested the 440 extensively at normal operating speeds and were satisfied with their design. What they hadn't done was test what would happen if someone tried to spin it to 7,000 RPM. Dick Landy wasn't just any mechanic. By 1968, he was already establishing himself as one of the premier Mopar racers in the country. Operating out of his Dodge dealership in Clifton Heights, Pennsylvania, Landy had a reputation for finding speed where others couldn't. He'd been racing since the 1950s, and by the mid-60s, he was a factory-backed racer for Chrysler. But unlike some factory teams who simply bolted on parts sent from Detroit, Landy was constantly experimenting, constantly questioning why things were done a certain way. The problem Landy faced was simple. Many of his customers wanted to go drag racing, but they couldn't afford Hemis. They were stuck with 440s that gave up too much power to be truly competitive in superstock racing. The NHRA rules were strict. You could change certain components, but the basic engine architecture had to remain stock. You couldn't add a supercharger or turbo. You couldn't increase displacement. You had to work within the rules, and those rules seemed to favor the guys with Hemis. So Landy started analyzing the 440's weaknesses. The heads flowed reasonably well, not Hemi level, but respectable. The bottom end was bulletproof, with forged pistons, and a forged steel crankshaft that could handle serious abuse. The intake, manifold, and carburetor could be upgraded within the rules. But when Landy tried to rev the engine past 5,500 RPM, power fell off dramatically. Push it to 6,000 RPM, and the power curve didn't just flatten, it nosedived. Here's where Landy's mechanical intuition kicked in. He noticed that the valve springs were the first component to give up. At high RPM, valve float was occurring. The valves weren't following the camshaft lobe properly. They were bouncing off their seats, failing to open fully, and destroying the engine's ability to breathe. The springs simply couldn't control the valves at racing speeds. Now, most people would have looked for aftermarket racing valve springs. There were plenty available from companies like Isky and Crane Cams. But Landy had a different idea. He looked at the Hemi valve springs sitting on his shelf. These springs were designed for an engine that regularly saw 7,000 RPM in competition. They had a seat pressure of 130 pounds and open pressure of 320 pounds. Significantly stiffer than the 440's springs, but not so radical that they'd destroy a hydraulic cam. The beautiful part? The Hemi valve springs were almost identical in dimensions to the 440's springs. Same installed height, same coil diameter, same overall length. They'd fit without any machine work, without any modifications to the cylinder heads or valve train geometry. It was almost like Chrysler had designed them to be interchangeable, though that certainly wasn't intentional. Landy installed a set of Hemi springs in a customer's 440 and took it to the track. The transformation was immediate and dramatic. The engine that previously fell on its face at 5,500 RPM now pulled strongly to 6,800 RPM. Some careful tuning pushed that to 7,000 RPM. That extra 1,500 RPM of usable power band translated directly into horsepower. Remember, horsepower is torque multiplied by RPM divided by 5,252. Even if torque stayed the same, those extra revs meant extra power, but torque didn't stay the same. With the valves properly controlled, the engine could breathe at high RPM. The improved cylinder filling actually increased torque throughout the upper RPM range. Dyno testing showed the spring swap alone was worth 75 horsepower. Add a more aggressive camshaft that could take advantage of the higher rev limit, and you were looking at a 100 horsepower gain. The 375 horsepower grocery getter had become a 475 horsepower race engine. Let's talk about what was actually happening inside that engine. At 7,000 RPM, each valve is opening and closing 58 times per second. The valve spring has approximately 8 milliseconds to open the valve, hold it open at maximum lift, then slam it shut and keep it sealed against combustion pressure. The stock 440 springs simply didn't have enough tension to accomplish this at high speeds. They'd compress under the cam lobe's pressure, but they couldn't extend fast enough to follow the lobe back down. The valve would float in space, neither fully open nor fully closed. This valve float caused multiple problems. First, it restricted airflow. A valve that's supposed to be open half an inch might only open 3/8 of an inch. That's a 25% reduction in flow area. Second, it affected timing. Valves that didn't close when they should disrupted the carefully orchestrated dance of intake, compression, combustion, and exhaust. Third, and most dangerously, floating valves could collide with pistons, turning your engine into very expensive scrap metal. The Hemi springs eliminated all these issues. Their higher spring rate meant they could follow the cam lobe precisely, even at speeds the 440 was never designed to achieve. The valves opened fully, closed completely, and did so exactly when the camshaft commanded. The engine could finally breathe at high RPM, and breathing is everything in naturally aspirated racing. But Landy didn't stop there. He realized that if the 440 could now rev to 7,000 RPM reliably, other modifications could multiply the gains. He started with camshafts. The stock 440 cam was designed for low-end torque and smooth idle. With 256 degrees of duration, it was already giving up by 4,500 RPM. Landy experimented with hemi-grind camshafts, eventually settling on profiles with 284 to 292 degrees of duration and 0.500 to 0.520 inches of lift. These more aggressive profiles took full advantage of the higher rev limit. Next came cylinder headwork. The 440's heads weren't bad, but they weren't optimized for high RPM operation either. Landy found that careful porting of the intake and exhaust ports, larger valves from the 446-pack engine, and multi-angle valve jobs could improve flow by 20%. Combined with the spring swap and cam upgrade, properly prepared heads pushed power output past 500 horsepower. The intake manifold was another restriction. The stock cast iron intake was designed for good street manners and hood clearance. Landy preferred the aluminum Edelbrock CH28 or the later Chrysler aluminum 6-pack intake. These high-rise designs improved airflow to the center cylinders and allowed for larger carburetors. Speaking of carburetors, the stock Carter AFB 4-barrel was replaced with an 850 CFM Holley double pumper that could feed the engine's appetite at high RPM. Headers were mandatory. The stock exhaust manifolds were horrible bottlenecks, especially on the driver's side where the steering column forced a compromised design. Landy used 2-inch primary tube headers that improved exhaust scavenging and added another 20 horsepower. The ignition system got attention too. The stock single-point distributor was marginal at 5,000 RPM and completely inadequate at 7,000. A dual-point distributor or early electronic ignition system ensured consistent spark at maximum RPM. Here's where things get really interesting from an engineering perspective. Landy discovered that the 440's bottom end was actually overbuilt for its intended use. The forged steel crankshaft, forged pistons, and beefy connecting rods could handle far more stress than a 5,000 RPM street engine would ever generate. This was a happy accident of Chrysler's part-sharing strategy. The same bottom-end components were used in truck engines that needed to survive years of commercial abuse. That overbuilding meant the 440 could handle racing speeds without expensive bottom-end modifications. The oiling system needed minor help. At 7,000 RPM, oil pressure could drop in hard corners as G-forces pushed oil away from the pickup. A simple windage tray and baffled oil pan solved this. The cooling system was another story. Spinning an engine 40% faster than designed generated significant extra heat. Landy recommended high-flow water pumps, larger radiators, and sometimes oil coolers for extended racing sessions. By late 1968, Landy's Hemi Spring 440s were showing up at drag strips across the country and shocking the establishment. In NHRA Superstock racing, where cars are classified by weight and horsepower, these modified 440s were competing directly with Hemis and winning. The best part? The entire modification package cost less than $300 compared to the $2,000 premium for a Hemi. Let me put this in perspective. A properly built Landy Spec 440 could run the quarter mile in the high tens at over 130 miles per hour. That's supercar territory even by today's standards. A stock Hemi car might be a tenth or two quicker, but at a fraction of the cost, the 440 was the performance bargain of the century. And because the 440 was available in everything from Plymouth Satellites to Dodge Chargers to Chrysler New Yorkers, you could build a sleeper that looked completely stock but would embarrass Corvettes and Cobras at the stoplight drags. The racing community took notice immediately. In 1969, Landy's customer cars dominated their classes at the NHRA Winter Nationals and won numerous divisional championships. Other racers started copying the formula, and soon Landy-built became a badge of honor in Mopar circles. Dodge dealerships started advertising Landy-tuned cars, and performance shops across the country began offering the spring swap as their secret weapon. But here's the kicker. When word got back to Chrysler Engineering about what Landy had discovered, they were simultaneously impressed and embarrassed. How had they missed something so simple? The answer lay in their testing protocols. They'd never pushed the 440 to its limits because that wasn't its intended mission. They'd optimized it for one purpose, and never considered that it might have untapped potential for another. Some Chrysler engineers actually visited Landy's shop to see these modifications firsthand. They dyno-tested his engines, took them apart, and analyzed every change. Their conclusion? Landy had essentially created what the 446 pack would become in 1969, a high-performance version of the 440 that could compete with the Hemi at a lower price point. The main difference was that Landy had figured it out a year earlier using parts that already existed. The 446 pack, introduced mid-year 1969, incorporated many of Landy's discoveries. It featured stiffer valve springs, not quite Hemi spec, but much stronger than the standard 440. It had a more aggressive camshaft with 276 degrees of duration. It used 3 two-barrel carburetors on an aluminum intake manifold. And yes, it was rated at 390 horsepower, though real output was closer to 450. Chrysler had essentially productionized Landy's hot rod recipe. This raised an interesting question in the Mopar community. If the 440 could be made this powerful with simple modifications, what was the Hemi's real advantage? The answer became clear on the dyno. While a modified 440 could match a stock Hemi, a modified Hemi was in another league entirely. Those hemispherical combustion chambers and massive valves gave the Hemi a ceiling that the Wedge simply couldn't match. Racing Hemis were making 600-plus horsepower in superstock trim and eventually over 700 horsepower in pro stock configuration. But for the average racer, that didn't matter. They weren't building all-out pro stock cars. They wanted to go fast on a budget, and Landy's 440 formula delivered exactly that. It democratized Mopar drag racing, allowing working-class racers to compete with wealthy Hemi owners. A mechanic making $5 an hour could build a competitive race engine in his garage using mostly stock parts and some careful machine work. The influence of Landy's discovery extended beyond just valve springs. He'd proven that factory engineers didn't always fully explore their engine's potential. This inspired a generation of hot rodders to question assumptions and experiment with unconventional modifications. If something as simple as valve springs could unlock 100 horsepower, what other hidden performance was waiting to be discovered? Landy himself became a legend in Mopar circles. His Landy's Dodge Dart race cars were famous for their consistent performance and innovative engineering. He won multiple NHRA national events and became one of the first racers to run 9-second quarter miles in a stock-bodied car. But racers always remembered that his reputation started with those $60 valve springs that outsmarted Chrysler's best engineers. The technical legacy is fascinating. Landy's work demonstrated the importance of valve train stability in high-performance engines. Today, every serious performance engine uses sophisticated valve springs designed specifically for its intended RPM range. Modern engines use beehive springs, dual springs with dampers, and even pneumatic valve actuation in Formula One. But the principle Landy discovered remains unchanged. You can't make power if the valves won't follow the cam. His discovery also highlighted the interconnected nature of engine systems. The valve springs weren't just about valve control. They enabled higher RPM, which required better oiling, more cooling, stronger ignition, and increased fuel flow. One modification cascaded into a dozen others, each building on the previous, to create a complete performance package. This systems thinking approach became standard practice in engine building. From a business perspective, Landy's discovery was revolutionary. He'd found a way to deliver Hemi-like performance without Hemi prices. This created an entirely new market segment, the budget performance customer who wanted to go fast without going broke. Thousands of 440-powered cars were built to Landy's specifications, generating millions in part sales and establishing a cottage industry of 440 performance specialists. The story also illustrates the difference between engineering for production and engineering for performance. Chrysler's engineers weren't wrong in their valve spring selection. For a luxury car engine that would spend its life between idle and 4,000 RPM, the soft springs were ideal. They reduced noise, improved fuel economy, and extended component life. But by optimizing for one use case, they'd inadvertently limited the engine's potential in another. This is a crucial lesson in engineering. Every design decision involves trade-offs. Softer springs meant quieter operation, but limited RPM. Mild camshafts meant smooth idle, but reduced high RPM power. Lower compression meant regular gas compatibility, but less efficiency. Chrysler chose reliability and refinement over raw performance. Landy simply changed the equation, accepting slightly more noise and wear for dramatically more power. The economic impact was substantial. Consider that thousands of racers chose 440s over Hemis specifically because of Landy's modifications. At a $2,000 price difference per car, we're talking millions of dollars in lost revenue for Chrysler's Hemi program. But it also meant more people could afford to go racing, expanding the market and ultimately benefiting the entire performance industry. Modern engine builders still reference Landy's work. When someone builds a 440 today for vintage drag racing or a resto-mod project, they almost always start with upgraded valve springs. It's become so standard that many people don't even know why they're doing it. They just know that everyone upgrades the valve springs on a Ford 40, not realizing they're following a tradition started by a Pennsylvania mechanic who refused to accept conventional wisdom. The story has parallels throughout automotive history. Hot rodders discovering that Ford flatheads could be improved with multiple carburetors. racers learning that small block Chevys responded to high winding, tuners finding that Japanese engines could handle massive boost with proper preparation. In each case, someone looked beyond factory specifications and found untapped potential, but few discoveries were as simple, cheap, and effective as Landy's valve spring swap. There's also a fascinating what-if scenario to consider. What if Chrysler had discovered this potential themselves and built the 440 as a high RPM screamer from the start? Would the Hemi have been necessary? Would Mopar's racing history have been different? We'll never know, but it's intriguing to imagine an alternate timeline where the 440 was the apex predator and the Hemi never needed to exist. The broader lesson extends beyond just engines. How many products, systems, or processes do we use daily that have untapped potential? How many assumptions do we accept without questioning? Landy's discovery reminds us that expertise doesn't always come from engineering degrees or corporate R&D departments. Sometimes it comes from hands-on experience, curiosity, and the willingness to try something different. From an engineering ethics perspective, Landy's story raises interesting questions. He was essentially revealing that customers had been sold an artificially limited product. The 440 could have made more power from the factory with minimal cost increase. But would customers have wanted a louder, higher maintenance engine in their luxury cars? The answer is probably not, which validates Chrysler's original decision while also validating Landy's modifications for a different market. This is the beauty of hot rodding culture. It's not about accepting what manufacturers provide. It's about pushing boundaries, finding limits, and then exceeding them. Landy embodied this spirit perfectly. He didn't just bolt on parts and hope for the best. He analyzed, tested, and understood why modifications worked. His approach was scientific, methodical, and repeatable. That's why his modifications became gospel in the Mopar community. The story continues today. While original 440s are becoming rare and valuable, the Landy modification lives on. Modern stroker kits turn 440s into 500-plus cubic inch monsters. Aluminum heads flow better than anything available in the 60s. Electronic fuel injection and modern camshaft profiles push power levels beyond what Landy could have imagined. But at the core of every built 440 are those upgraded valve springs, controlling valves at RPMs that would have seemed impossible in 1968. Classic car auctions regularly feature Landy-built or Landy-style 440 cars commanding premium prices. Documentation showing a connection to Landy's shop can add tens of thousands of dollars to a car's value. His signature on an engine block is like a certificate of authenticity for Mopar collectors. The man who outsmarted Chrysler with $60 in valve springs became an icon whose name adds more value than any factory option. The technical specifications tell the story in numbers. Stock 440, 375 horsepower at 4,600 RPM, 480 pound-feet of torque at 3,200 RPM. Landy modified 440, 475. Horsepower at 6,800 RPM, 490 pound-feet at 4,500 RPM. 100 horsepower gained, peak power RPM increased by 2,200, and the torque peak moved up 1,300 RPM, all from valve springs that cost $60 in 1968, about $500 in today's money. That's the best dollar per horsepower modification in automotive history. Think about what this meant for bracket racing. A racer with a Landy 440 could compete in a lower, less competitive class while running times that belonged in higher classes. They could win more rounds, earn more prize money, and build their reputation without the massive investment a Hemi required. It leveled the playing field in a sport where cubic dollars usually meant cubic inches, and cubic inches meant winning. The story also demonstrates the importance of being in the right place at the right time. Landy was a Dodge dealer mechanic with access to both 440s and Hemi parts. He had the facilities to test modifications properly. He had customers willing to try unconventional solutions. and he had the reputation to make his discoveries credible to the wider racing community. Another mechanic might have made the same discovery and been ignored, but Landy didn't just get lucky. He'd spent years building his expertise, establishing his credibility, and earning the trust of racers. When he said valve springs would transform a 440, people listened because he'd been right before. His discovery wasn't an accident. It was the result of systematic investigation by someone who understood engines at a fundamental level. As we look back from our modern perspective, with computer-designed valve springs and precisely calculated spring rates for every application, Landy's discovery seems almost quaint. Of course, valve springs matter. Of course, they need to match the intended RPM range. But in 1968, this wasn't obvious. High-performance engine building was still part art, part science, and part voodoo. Landy helped move it toward science. The environmental angle is interesting too. By making existing 440 engines more powerful, Landy's modifications meant fewer Hemis needed to be built. Each Hemi required special casting processes, unique machining operations, and exotic materials. The 440 used conventional manufacturing techniques. In a roundabout way, Landy's discovery was more environmentally friendly, though nobody was thinking about that in 1968. The story reaches its crescendo when you realize that Dick Landy didn't just find a way to make 440s faster. He changed the entire Mopar performance hierarchy. Before Landy, it was simple: Hemis on top, everything else below. After Landy, there was a middle ground. A 440 with the right modifications could run with Hemis on the strip while being more streetable and affordable. This created the muscle car sweet spot that defined the late 60s and early 70s. Today, when someone builds a period-correct 440 for their restored Roadrunner or Charger, they face a choice: keep its stock for originality or add Landy's modifications for performance. Most choose performance, because driving a car with an extra 100 horsepower is more fun than having matching numbers. Landy's discovery means these cars can be enjoyed, not just displayed. They can be driven hard, raced occasionally, and still maintained by any competent mechanic. The legacy lives on in unexpected ways. Modern Chrysler engineers, now working for Stellantis, still reference Landy's work when discussing valve train dynamics. His discovery is taught in automotive engineering courses as an example of how production constraints can mask performance potential. Hot Rod magazine has referenced the Landy valve spring modification in dozens of articles over 5 decades. Dick Landy passed away in 2007, but his contribution to automotive performance remains immortal. Every time someone installs stiffer valve springs to raise an engine's RPM capability, they're following his blueprint. Every time a racer finds hidden performance through careful analysis rather than throwing money at a problem, they're honoring his methodology. The Pennsylvania mechanic who outsmarted Dodge's engineers with a $60 modification proved that innovation doesn't always come from corporate laboratories or million-dollar development programs. Sometimes it comes from a guy in a garage who asks the right question at the right time and has the courage to challenge conventional wisdom. Dick Landy didn't just modify engines, he modified the entire understanding of what those engines could do. What's your favorite David versus Goliath story from automotive history? Drop a comment below and share what clever modification or discovery changed the game in your world. And if you enjoyed this deep dive into Dick Landy's genius, make sure to subscribe, because we're just getting started exploring the legends and innovations that built American performance. Until next time, keep questioning assumptions, and remember, sometimes the best solution is the simplest one nobody else thought to try.